modified distribution method. So when given a transportation problem, you first use the northwest corner method or the VAM method, or that's the Volta's approximation method, to draw your initial solution. After that, then use the modified distribution or the stepping stone to calculate or to get your optimal tableau. So in this method, what we are going to do is that we are going to assign UI values for each row, and then I'm going to assign UI values for each row, and then VJ values for columns. Value of 0 to U1, that's the initial value, or the first row is the first row, so that's going to be 0. Always remember this. So always U1 is equal to 0. Then we compute the net costing for each non-basic variable. So after we use the allocated cells to calculate for the values of U, the UI values and the VJ values, and then we use these same values using the expression. The net costing is equal to the Cij value minus UI minus Vj. So this will give us the net costing value. After that, we will compare the values. If we have a negative value, it means that the solution is not optimal. So we take the most negative value, and then according to the stepping stone process, using the step 1, we find a closed loop and then do the allocations again, and then we draw another table and then calculate for the new UI and VJ values. Then we continue the process until all our net costing values are positive. Until all of them are positive, our solution is not optimal. So let's get started. All right. So we are going to assign our UI and VJ to the rows and columns respectively. So here is going to be U1, and here is going to be U2, U3, and here is going to be V1, V2, V3. But remember, always U1 is equal to 0. So we are going to use the relationship, this equation, UI plus Vj is equal to Cij. All right, so for cell X11, we are going to get, what's the UI value here? 0. What's the VI value? VI value here, we don't know. So VI is equal to the Cij value here is 8. So it's equal to 8. So from here, you can say our VI is equal to 8. So we do same for this one. We are doing for only the allocated cells. So we move to the next one. That's X12. Sorry, X21. X21. And then that will be U2 V1. So U2, we don't know the value. So U2 plus, we know our value for V1, which is what we had here. That's 8. So plus 8 is equal to this value, equal to 15. So when 8 cross to the other side, we are going to have U2 to be equal to 15 minus 8, and that's going to give us 7. So for 3-1, sorry, this is the 3-1 is not an allocated cell. You don't have, it's not an allocated cell. So the next allocated cell is here, and that's 2, 2. So for X22, we are going to have, what's the value for U2? Is 7 plus, you don't know the value for V2, so V2 is equal to the Cij value 10. So therefore, V2 is equal to 10 minus 7, and that's going to give us 3. So we move to the next one. We move to the next, that's this is the next allocated cell. So X 23, sorry, X32. This gives us, what's the value for U3? We don't know, we've not calculated it yet. U3 plus V2. So we've already calculated V2, and it is, so V2 is 7 right there. and then v2 is 3. So u3 plus the v2 is 3 is equal to this value 9. So therefore, we have our u3 to be equal to 6. 9 minus 3, that will be 6. We move to the next one. That's the next allocated cell. That's x33. This is the next allocated cell. We already know our u3 to be 6. So 6 plus v3 is equal to this value 10. So therefore, v3 is equal to 10 minus 6, that's 4. All right, so we know our vi and vj values. We know all. So what we are going to do is to check for optimality. That we are going to calculate for the value of each non-basic variable, the net costing for each non-basic variable. And as I said earlier, the net costing is equal to Cij minus Ui minus Vj. So let's do that here. All right, so let's look at the unallocated cells. So let's start from here. That's going to be, let's start from here. That's going to be C12. So C12 is equal to, what's the Cij value? That's 5 minus the U value, that's 0, minus Vij 3. So that's going to give us 2. Then we move to the next one, C13. C13, this one. What's the Cij value? The Cij value is 3. So 3 minus this, the U value here is 6. 6. Sorry, this is supposed to be 3 1. 6 minus this one 8. So 3 minus 6 minus 8, that's going to be minus 11. So we are done with this one. We are done with this one. We move to the next one. That's the C13. So the value here is 6. So we have 6 minus here is 0. 6 minus 0 minus this one, the V value. We have V3 to be 4. So 6 minus 0 minus 4. And that's going to give us positive 2. So our next one, we calculate for 2, 3, this one. That's going to give us 12, because we have this one to be 12, minus 7, minus 4. You know how the u value here is 7. So 7 and this 4. So 12 minus 7 minus 4, that's 1. All right. So these are our net costing values. And then we have a negative number here, which means that our table is not optimal. So minus 11. And that's in which cell? That's the 3 1. This is C31. So where is C31? We find our C31. Then we draw a closed loop. I want to clean. Let me clean these marks here. All right, so this is C31. So we start here, we form a closed loop. We start with positive here. Which direction are we going? Should go this way. Minus, plus, minus. So we check the negatives. This one and this one. Which one is the minimum? 20 is the minimum. So we add 20 here. We subtract 20 here. So we have 10 left. And then we add 20 here, making it 70. So here we'll go to 0. So let's draw our table again. Let me draw it here so that I can see. Or okay, let me put it here. We don't need those values here. Oh. All right, so here I write down my values. Here is 8, and then 120. This one will now go to 10, and then 15. Here is now 20 and 3. This one will now go to 0, and here we'll go to 70, and then 10, and then this one will be 5. No allocation. So 1, 2, 3, 1, 2, 3. This is demand. Here is 150, 70, 60, 280. We have 80 here, 80, 120. So the rest remains the same. It remains unchanged. Yes. So this is our next table. This is our next table. This is our new table. So we have to also repeat the same process to check if this our new table is also optimal. You have to repeat the process and check if it is optimal. So what do? We repeat the same process. We calculate we assign the u values and the v values. Then we calculate for them. Then we check for optimality. We calculate the net cost change. All right. So let's do that. Let's do that. So let's look at the allocated cells. That's what we are going to use to calculate for the u and v value. So from cell 1, we are going to have this 8, or we are going to have u1 plus v1 to be 8. So u1 plus v1 is equal to 8. Normally, this is the expression ui plus vj is equal to c minus ij. Yes. So this 8, but we know that our ui value is always 0. So therefore, v1 is equal to 8. So we move to the next allocated cell, that's C21. So C21, that's U2 plus V1, that's equal to, sorry, that will be equal to 15. So therefore, we know that our V1 is 8. So let's clean it and write it. So 8. So therefore, U2 is equal to 15 minus 8, and that will give us positive 7. So we move to the next allocated cell, that's C22. C22, this one. So we are going to have U2. We already know the value of U2 to be 7. So 7 plus, what's the value of V2? We don't know. It's equal to 10. So therefore, our V2 will be equal to 3. 10 minus 7, that's 3. So move to the next allocated cell, that's C31, this cell. We already know do we know our U3? No, we've not calculated that yet, but we know V1. All right, so U3 plus, what's the value for V1? 8 is equal to 3. So therefore, our U3 is equal to 3 minus 8. That will give us minus 5. Move to our next allocated cell, that's C33. All right, so we know our value of U3 to be minus 5, but we don't know our value for V3. So minus 5 plus V3 is equal to 10. So therefore, V3 is equal to 10 minus 5. This minus 5 is crossing to the other side, so it will be positive. So 10 plus 5, that will give us 15. So now we know all our V and U values. We know all our V and U values. So what do? We go ahead and then calculate the net cost change and then see if our table is optimal. And that one we use the expression CIJ, that's the net cost change asterisk, is equal to CIJ minus UI minus VJ. So this is what we are going to use. This formula is what we are going to use to calculate for the net cost change, check for the optimality. So let's start it. Now we are going to do that for unallocated cells. Use the allocated cells to calculate for your V and U values, and then you use the allocated cells to check for optimality. So let's start. Let's start with this cell. That's C12. So C12 is equal to, what's the Cij value there? 5. So 5 minus the U value 0 minus the J value, V value, that's 3. So minus 3 is equal to 5 minus 3 is 2. Then the next unallocated cell is here. That's U13, C13, sorry. C13, that's equal to, the Cij value here is 6. So 6 minus, what's the U value? 0. And then the V value is 15. So 6 minus 15, that's going to give us minus 9. The next unallocated cell here is this. That's C23. C23. And the Cij value there is 12. So 12 minus, what's the U value? 7. So minus 7 minus the V value, that's 15. 12 minus 7 minus 15, that's going to give us minus 10. And then our next unallocated cell is this cell. That's C32. So C32. The next question will be the Cij value minus U minus V. And the Cij value here is 9. 9 minus the U value. That's minus 5 minus the V value. That's 3. So 9 minus 5 minus 3. So the minus 5 is going to be positive. So 9 plus 5. That's 14. 14 minus 3. That's 11. So these are our net change. Since we have a negative value, we have negative values. This one is negative values. It means that our solution is not optimal. So we take the most negative value, and the most negative value is minus 10. So our most negative value is minus 10, and that's, so C23 and base 23. This is 23. So you start with plus, minus, when you move to this side, plus, and then minus. So we look at where we have, so this is a complete closed loop. You can skip. So from here it goes this way, it goes this way. So let me use a different color so that you can see the directions. So it goes this way, then to this way. So that's a closed loop. So what do? We look at the negative, the cells with the negatives in the closed loop. So this is having a negative polarity, this one is having negative. Then we take the minimum number. So the minimum number is 10. So we add 10 here because we have plus here. We subtract 10 from here, so we are going to get 50. We add 10 to this one, so we are going to get 30. And here is negative, so 10 minus 10, so we are going to get 0. Yes, so this is what we are going to use to draw our new table. New table. All right. So 2 from. So 1, 2, 3. 1, 2, 3. Then we have 120 here. This one is now 0, so unallocated. The other one is now 30. 3 here. This one is having 15. And then 5, 10. Now we didn't touch it, so it's 270. So now this cell is unallocated, but it's now having 10. Then our 12 will be here. There's going to be 6. We are going to have 10 here. Now here is 50. So I think that is it. So we are going to proceed and then find our new UI and then VJ values. We are going to proceed and find our new UI and VJ values. So this is u1. You know that one is always equal to 0. u2, u3, v1, v2, v3. We have our supply here. We have demand. So here it's still 150, 70, 60, 280, 80, 80, 120. All right, so let's go ahead and calculate for our new V and U values. So let's start with the allocated cells. Sorry, let's start with C11. So we have here to be, we have our U1 value to be 0. You already know the expression. Cij is equal to Ui plus Vj is equal to Cij. So this is what we are in. Our U1 value here is 0. So 0 plus our V1 value, we don't know. So V1 is equal to our Cij value here, 8. So therefore, V1 is equal to 8. So we'll move to the next allocated cell. Next allocated cell in this row, we don't have any allocated cell again. So we'll move to the next one here. That's C22. Okay, so we move to the next allocated cell. That's this cell, C22. So C22, we have U2 plus V2 to be equal to 10. But you can see that you don't know the value for U2 and you don't know the value for V2 as well. So we can just write it like that and go ahead for the rest. By the time we finish, we get the values and then bring it back to get that of the other value. So we'll just leave it this way. Let's move to the next allocated cell. The next allocated cell is C23. This one. So that one involves U2 plus V3, which is equal to 12. And that one too same. We don't know any of the values, so we just leave it like that and move to the next allocated cell. That's this cell, C31. For C31, we already know the value for V1, that's 8. So U3 plus V1, so V1 is 8, is equal to this value, 3. So therefore, U3 is equal to 8, 3 minus 8, that's going to give us minus 5. And then we move to the next allocated cell, that's the last one, C33. So that's going to give us U3 plus V3. But we already know our value for U3 to be minus 5. So minus 5 plus V3 is equal to 10. So therefore, V3 is equal to positive 15. 10 plus 5. So we now bring the value for V3 here to get our value for U2. So we have this to be 15. This means that if it's crossed to the other side, we are going to have 12 minus 5. That's going to give us minus 3. So therefore, U2 is equal to minus 3. And then we have U2 to be minus 3. So we will take it back to this equation. So U2 is minus 3. So we have minus 3 plus V2. And that's going to give us 10 plus 3. So we have our V2 to be equal to 13. Yes, so that's it. Now we have our VI and, sorry, UI and VJ value. So let's check for optimality. We are going to do that by calculating the net cost change. That's Cij minus Ui minus what? Vj. So let's write our values so that it's simple for us. V2 was 13 and then V3 was 15. And then U3 was minus 5 and then U2 was minus 3. So we are going to do that for unallocated cells. So let's start with here. That's C1, 2. That's the Cij value. What's the Cij value there? That's 5. So 5 minus 0, the U value 0 minus 13. That's going to give us minus 8. And then the next unallocated cell is here, C13. That's going to give us the CIJ value there is 6. So 6 minus the U value 0 minus 15. That's the V value. That's going to give us minus 9. And the next unallocated cell is C21 here. C21 here. The CIJ value is 15. So 15 minus the U value minus 3 minus the V value minus 8. And that's going to give us positive 10. We are going to do that for the next unallocated cell, that's here. So I didn't write the CIJ value. Let me check. Above 70, that's 9. So 9. So our CIJ value is, sorry, 6, C32 is 9 minus all the U value, that's minus 5. So minus 5 minus the V value, that's 13 minus 13. Yeah, minus 13 rather. Sorry. So 13. And this is going to give us 1. All right, so we still have negative numbers here, which means that our solution is still not optimal. So we have to do another iteration, or we have to draw another table. So we have to take the most negative number, and that's negative 9. And negative 9 is in which cell? That's C13. 1 3. So where is 1 3? This 1 3. So this cell. Let me clean my writings in the table so that you can clearly see how I'm going to do it. All right, so C13. So that's this cell. So we are going to assign the polarity. So here is positive. You have to get a closed loop on the allocated cells only. So when we come to this side and go and move to this side, when we move to this side and move to this side, you see we can't move diagonal too. That would be difficult. No, here is an unallocated cell. So that part is not good for us. So the best part is to just move to this side here. So negative here, we bring positive here, negative here. So our path is now this way. So this way, that's our closed loop. All right, so what do? We check where we have the. So what do? We look at where we have the negative polarity. So this cell and then this cell. Then we take the minimum number. So the minimum here is 50. We have 120 and we have 50. So the minimum is 50. So we add 50 here. Let me say different color. So we add 50 here. So 50 plus 30, that's going to give us 80. That will be the new value for this cell. We have 120 here. So 120 minus 50. And that's going to give us 70. Then we come to this cell, we add 50. There's nothing there, it's unallocated. So we are going to get 50. And here 50 minus 50, we are going to get 0. So that would be the new allocation. So let's redraw our table again. Let's draw our table again and then check for optimality. Alright. So we have 2, 1, 2, 3. We have demand here. We have supply. 120, 80, 80, 280, 60, 70, 180. So let's look at our allocations. We have 70 here, and the value here is 8. And then here we don't have any allocation. Our new allocation for this cell is 50. And then, sorry, here is 5. And then here is 6. We have 10 here, and then 12. We have 70 and 10. We have 15 here. We have 80 and 3. Then here we have 9. And then here we don't have any allocation here. Alright, so this is our new table. This is our new table. So we are going to repeat the same process how we do it. We are going to assign our U and then U and V values, UI and VJ values, and then calculate them using the allocated cells and then check for optimality. So let's do that. So always our U1 is 0, so U2, U3, V1, V2, V3. Alright, so let's compute for the U's and V's. So starting from here, that's C11. You already know the expression. We use the expression UI plus Vj is equal to Cij. That's what we use to calculate. So our UI value here, U1 value here is 0. We don't know our V value. So V1 is equal to 8. So therefore V1 is equal to 8. Then move to the next allocated cell in this row. That's here. C13. C13. So you know U1 to be 0. And then we don't know our V3. That's equal to 6. So therefore V3 is equal to 6. What's the next allocated cell? That's 22. So C22. U, U2. We don't know our U2 and then we don't know our V2 as well. So we just write down the equation. That one should be equal to 10. We leave it. Let's go. We come back to it. And then our next allocated cell is 2, 3. So cell 2, 3. Sorry, 2, 3. We have our U. We don't know our U2 value, but then we know our V3 to be 6. And that's equal to 12. So 6 will go to the other side. Then we are going to have our U2 to be equal to 6, 12 minus 6. So now we know our U2, so we'll bring it back here. So U2 is 6. So when 6 cross to the other side, we are going to have V2 is equal to 10 minus 6. So we are going to have our V2 to be positive 4. Then our next allocated cell is this one, 3, 1, cell 3, 1. Do we know our U3 value? No, but we know our V1 value. So U3 plus 8 is equal to 3. So therefore, our U3 value is equal to 3 minus 8, that's minus 5. So let's write down all our U and V values in our table. So U2 is 4, U3 is minus 5, and V1 is 8, V2 is 4, and then we have V3 to be equal to 6. Alright, so let's check for optimality. Optimality test. Alright, and we already know the formula to be the net cost change is equal to Cij minus Ui minus Vj. Alright, so starting from, we are going to do that on only the unallocated cells. So starting from here, so that's C12, C12. That's going to give us the Cij value there is 5. So 5 minus our U is 0 minus our V value there, that's 4. So 5 minus 4, that's positive 1. And our next unallocated cell is this one, that's C21. And our Uij is 15. Cij, sorry, is 15. Minus our U value, that's 4. And then our, sorry, think writing down our values here, our U2 is 6 here. 6 here, so that should be 6. That should be 6, not 4. So 6. So this is supposed to be 6. So 15 minus 6 minus our this one. So our V value there is 8. So 15 minus 6 minus 8, that's also 1. And then our next unallocated cell is here. That's C32. So the next cost change is the Cij value, that's 3, minus the U value, minus 5. Sorry, this is 9. Okay, so on our next unallocated cell is C32, that's this cell. Our Cij value is 9, and then our U value is -5 minus our V value, that's 4. So 9 plus 5 minus 4, that's going to give us 10. Alright, so our next unallocated cell is here. So C33 is equal to our Cij value there is 10 minus the U value -5 minus the V value, that's 6. So 10 plus 5 minus 6 is 9. So we can conclude that our table is optimal, or we now have our optimal solution. Since all our Cij values for the net costings are greater than or equal to 0, it implies that it is not possible to reduce costs further. Therefore, our current solution is optimal. So that is it for modified distribution method. Thank you for watching this video and see you in another video. In case you have a question, you can type it in the comment section and then we will get back to you. Thanks.